So this is how an induction loop senses when a car is at a traffic light. There are grooves cut in the road, and a loop of wire, typically 5 feet in diameter with 5 or 6 loops, is put into the grooves. An inductance meter is then connected to the loops of wire and the traffic light to form a circuit.
Once the car drives over the loop, the inductance increases. The metal of the car acts as the core of the inductor when it enters the magnetic field of the loop.
The traffic light sensor and the inductance meter constantly check the inductance of the loop. When the inductance increases, it signals to the traffic light that a car is waiting and the light changes.
The capacity of an inductor is controlled by two factors, the number of coils and the core, or the material that the coils are wrapped around. The greater amount of metal in the core, the greater the inductance. Not all vehicles have enough metal for the light to change, including motorcycles and bicycles. However, a neodymium magnet can be placed perpendicular to the road on the vehicle to increase the inductance and thus trigger the light.
This technology is useful in our everyday lives by preventing drivers from sitting and waiting at a red light and keeping traffic moving. Other technologies sometimes used to signal to the light the presence of a car include hoses filled with air, radar, lasers, and cameras. However, the inductance loop is by far the most reliable and weatherproof.
So here we have a drawing of the situation where the metal car comes to the intersection and the light is red. He then goes onto the plate, which enters the electrical field, where the induction meter reads that the induction increased, which then, connected to the system computer, transfers the light, and instead of being red anymore, it turns green because it entered the magnetic electrical field and triggered once it went on top of the wires, which hold the wire, and then triggered the light to turn green. Loop induction, everyone.